Hello everyone. In this video, we will do an example for arc length of a curve given by graph of a function. So remember that arc length of such a curve is given by integral from a to b of square root of 1 plus the derivative of the function squared and then dx. Here in this case, the function is x squared, so its derivative is 2x. It's a continuous one, so we can apply the formula. A here is 0 and b is half. So the integral which gives us the arc length is 0 to half of 1 plus 2x squared dx. And this is 0 to half of root 1 plus 4x squared dx. Well, if you factor out 4, you get 1 over 4 plus x squared, and that shows us that the substitution, the trig substitution half of tan theta works here. So I won't factor out that 4 and use just that substitution. Du in this case is going to be half of secant squared theta. So my integral turns to 1 plus 4 times half of tan theta squared, half of secant squared theta d theta. How about the limits? Okay, so here, if x is 0, then half of tan theta is going to be 0, so then theta is going to be 0. Well, here you have to choose the theta which is in the domain or in the range of tan inverse, and if x is half, then half of tan theta equals to half. That implies that tan theta is equal to 1, and the angle in the range of tan inverse, which has that tan, is pi over 4. So my integral, theta integral, will have limits 0 to pi over 4. Very nice. Now let's apply the substitution. Well, already applied. Apply the identities here. Under the square root, we have 1 plus tan squared, which is secant squared theta. Let me put this half outside, and then secant squared theta multiplied outside. Here now, absolute value of secant theta will come out, but since on the interval was 0 to pi over 4, secant is positive, so I don't need to keep the absolute value, and I'll drop it, and then I'll get this famous integral that we have evaluated several times. And now you can use different methods here. In particular, you can apply the angle, the reduction formula for powers of secant, which will give us half of secant theta tan theta plus half of ln of secant theta plus tan theta. Yes, and then go from 0 to pi over 4. So we can factor out that halves there and plug in pi over 4. Okay. That is evaluated the upper one minus 1 over 4 of secant 0 tan 0 plus ln of secant 0 plus tan 0. Okay, so tan of pi over 4 is 1. Secant of pi over 4 is 1 over cosine of pi over 4, which is 1 over root 2 over 2, which will simplify to root 2. Here's root 2, this is 1, and here is 0, so this will go away. This is 0, so that is just 1. Ln of 1 is 0. So the second part is completely 0. On the first part, we have half 1 over 4 of root 2 plus ln of root 2 plus 1. And that is the length of the curve defined by, well, actually parabola, yes. So this is parabola from 0 to half is equal to 1 over 4 root 2 plus ln of root 2 plus 1.